Hello everyone. In today's video, I wanna go over some stuff to do with unsigned and signed type and tell you about why we have unsigned type. And with the signed type, you can represent both positive and negative numbers. And with unsigned type, you can only represent the positive numbers, but it can represent a larger range of positive numbers. And before we head on, there are two terms you should have in mind, which are the most significant bit and the least significant bit. And let's say we have a binary number with these bits, and the leftmost bit is called the most significant bit, and the rightmost bit is called the least significant bit. And from now on, whenever you hear these two terms, you should have them in mind. And so let's think about what the largest number that data with declared with type can represent. And if you declare a type, and it's automatically declared with the signed type. And let's look at the size of cha, and I'll print out the size of cha here. Comment out this just for now. And if you look at the size of cha, it will give 1 byte. And because it is 1 byte, can it has 8 bits, and you can represent the data with 8 bits. So if you think intuitively that the largest number that it can represent is to fill in all the bits with one, and I've wrote that down. And if you count it from the lowest bit, 1, 2, 3, 4, 5, 6, 7, 8, it is composed of 8 bits. And if you turn this binary number to a decimal number, it will give 255, which is 2 to the 8 minus 1. And you can check it on your calculator. So let's assign 255 to chnum chanum, which is declared with the chart type, and I'll look at the result here. And before I run this, I'll just comment it out, and let's look at the result. Then it did not give 255, which we have expected earlier, but it has overflowed. And let's see how come it gave this number. Because signed type can represent both positive and negative numbers. The most significant bit is used as a sign bit, which determines the negative number. So if the sign bit is on, then this bit gives negative number, which will give minus 2 to the 7. And all the numbers following this bit will give the positive numbers, which will give 2 to the 6 plus 2 to the 5, and so on. And let's make it clear by actually calculating it. Minus 2 to the 7 plus 2 to the 6 plus 2 to the 5 plus 2 to the 4 plus 2 to the 3 plus 2 to the 2 plus 2 to the 1 plus 2 to the 0. It gives minus 1. And That is why, because this number cha now is declared as type cha, and it hasn't got any prefix, so it is automatically declared with signed. And because it was declared as signed, it most significant bit is number one. So this gave negative number, which is minus 2 to the 7, and following all the bits following it gave the positive numbers corresponding to the position of the bit. And so, what is the number that it can represent with signed type? It is filling all the bits with meaningful bits without filling the most significant bit. So it will be 2 to the 7 minus 1 is 127. And let's assign 127 here, and let's see the result. See, it gives 127. And one, what will happen if you add number 1 to it? Then for signed type, if you add number 1, you if you add number 1 to this binary number, it will give the binary number 1000, the bit rounding up to this bit, and so on. And the effective result is here. And as we saw earlier, because it's signed type, this most significant bit is used as the negative number. So this, because this we gives minus negative number, it will give minus 2 to the 2 to the 7. And let's check it here whether it matches minus 128 minus 2 to the 7. Yeah, you can see here that it matches minus 120. So let's turn it to unsigned, and let's assign 255 again, which is which is this number in binary form. And let's see the result. At this time, because the cha is declared with unsigned, it can represent this number, filling the most significant bit with 1. And let's see if you add number 1 to it, and what will happen if the data becomes more than the bits that the type is declared earlier. So if you add up number 1 to 255, which is 256, if you turn this to the binary number, it will give this number. And once the data exceeds the declared type, it does bit truncation. And you know actually know the how it works if you've watched my earlier videos. So let's assign 256, and let's look at the result, whether it gives number 0 because it has done bit truncation. Oh, 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 oh. 256 will give 0. See, it gives 0, and let's see if you add 1 more to this number, it is 256 plus 1 is 257, and it matches the number adding number 1 to this binary number, which was the bit representation of the earlier number 200, earlier decimal number 256. If you add 1 to it, it will give O, 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 O1, which will be the same as 257 in decimal number. So if you assign 257 here, and it will give number 1, and let's just see if it's true. See that it gives number 1. So up to this point, I've covered about why we use unsigned type, and to tell you the answer, it is to represent the larger range of positive numbers. And because of this, some problems can arise when you do operations related to signed and unsigned. If you have both um, both data type during your arithmetic and logical operations, and I'll cover that stuff in the following videos. So look forward to it and see you in the next video.